Ohm's law, power law formulas. Now we're going to put it all together. We've been having some fun, of course, entering formulas in our calculators using the scientific notation and actually the engineering notation. And so now we're gonna really practice using formulas. And actually, we might as well learn a few that are really cool. If you're going to be an electrician, you cannot graduate without knowing Ohm's law. It's not allowed. Ohm's law, what is that? Well, first I'll just write it down. It says E equals I times R. It's huge. Now, what are all these things? Well, E, I don't know why they use an E, but E stands for voltage. In fact, when I went to college, we used a V to stand for voltage, but not anymore. Things have changed. I guess that's better to use an E. So, okay, E stands for voltage. Voltage, which is in volts. And the abbreviation for voltage is a capital V. E is voltage in volts, and I'm going to say it's like a pressure. If you have a lot of voltage, it's because you have a lot of electrical pressure. That's what the E is. The I is called the current, and that's in amps. Capital A is your abbreviation for amps. By the way, there was a Mr. Volt out there, and there was a Mr. Amp out there, and they got these things named after them. Isn't that cool? Actually, Ohm is a person too, and he, there's all these people getting things named after them. Anyway, so I is the current in amps, and that's basically the flow, just like you think of a river current. This is not a river, it's electrons flowing, but it's a flow. It's the same thing, flow. So you got pressure, you got flow, and then this R thing. What's this R thing? Well, that's called the resistance, which is exactly as it sounds. The more you resist the flow, the higher your resistance. If you have double resistance, it's because you're resisting the flow twice as hard or something. And anyway, the units for resistance is, guess what? Ohms. Named after Mr. Ohm. And the symbol for ohms is a capital Greek omega. And I don't know how else to say resistance, so I'm going to say, well, resistance. So these three quantities, pressure, flow, and resistance, are related according to this formula. Now, it's not a bad idea, especially when you're first learning this formula, to sort of like chew on it. You should always chew on it. So if we chew on it, what's this saying? This is saying, like, let me just make up some numbers. Let's say you put in, let's say you had 40 volts. Well, one way to do 40 volts is to have I don't want to put the units, it's too confusing. 4 amps times 10 ohms, right? That looks lousy. It's a little better. So if you had a flow of 4 amps and a resistance of 10 ohms, say, okay, 10 ohms, you will have 40 volts. That's one way to do it. Notice what you could also do. What if you made the amps into 2 amps? You cut them in half. Well, if you still want the 40 volts, you're going to have to double the ohms, right? Half the current, double the ohms. That also gives you a 40. So maybe I'll even write that down. If you, let me say it this way. Let's say that what I really did is I doubled the resistance, and that cuts the current in half. And of course, you could say it either way. You can say, if I cut the current in half, it doubles the resistance. If I double the resistance, it cuts the current in half. These are all valid, equivalent, really, statements. Or let's say I did something like, this. Maybe instead of doubling the R, I cut the R in half. So let's say I made the 10 into a 5. Well, if I'm going to equal 40 volts, then this all of a sudden has to be an 8. So that 8 times 5 will still be 40. Now, this is assuming that you keep the same pressure. You apply the same pressure E. So what I do here, I halved the resistance. That doubles the current. And again, that's if you keep the pressure the same. And I'm going to ask you to just think about blowing through a straw. If you're blowing through a straw and you keep the pressure in your mouth constant, well, if you like squeeze on the straw in order to double the resistance, you're not going to be blowing as much through there, right? Because you've increased your resistance. It's keeping the same pressure. Of course, the other thing you could do is you could try to blow harder, but if we were keeping the same pressure, then doubling the resistance cuts the flow in half. But if you were to somehow cut the resistance in half, maybe all of a sudden the straw expands somehow and all of a sudden it's got a bigger diameter. Well, it's going to be a lot easier to blow through it. And so if you're maintaining that same pressure, you're going to have more current going through it and so on. So this is just, you play with these formulas. So the E, the I, the R, they're all related by this. And by the way, what happens if you double both? In fact, let's do it this way. Let's say, one more scenario here. Let's say you double the current and you double the resistance, both. So the 4 gets doubled to an 8, the 10 gets doubled to a 20. Now you've got 160 volts. You'd have to actually have 4 times the pressure in order to double both the current and the resistance, and so on. So anyway, that's enough playing with that formula for today. So you got to somehow remember, and you will eventually as you keep working these problems in my class and in the rest of your electrical classes, you will eventually remember E is for volts, it's in volts. I is for flow, current, it's in amps. R is for resistance, in ohms, with this funny symbol, omega, standing for ohms. I want to show you something cool. You can represent this formula. In fact, let me get this stuff out of the way so I can put it over here. You can represent this formula in a nifty kind of way that you may have seen before in a different electrical context, a book, Don's class, whatever. Sometimes they give you this little, like a circle. E equals E on the top, IR on the bottom. And the way this circle works is, let's say you want a formula for E. Well, you put your thumb over the E, and you're reading E equals I times R, right? That's exactly what this says, E equals I times R. Okay, let's say you wanted to solve for I. Oopsie. Let's say you wanted to solve for I. You put your thumb over the I, and what do you see? You see that the I is right there, E over R. Ain't that something? Of course, you could do the same thing over here. You could say, oh, I'm going to have to divide both sides by R, and you'll end up with I equals E over R. So you can do it that way if you like. But the circle is kind of a nifty little thing, I think, a nifty little tool of some sort. And lastly, if you wanted to solve for R, put your thumb over the R, like if I made this really, really dark, you wouldn't even be able to see it, right? And then you say, well, R must be what I'm looking at. And what I'm looking at is an E over an I. And therefore, that's the formula for resistance. Resistance equals E over I. So notice this is a 3-in-1. 3-in-1 formula. Cool, huh? I think so. And that's your Ohm's law. So that's 3 formulas. We've got a total of 12 we're going to see today, but that's 3. Here's 3 more. They come in the wrapped up in what's called Watt's law. Pretty sure it's called Watt's law. And it goes like this. It has to do with power. Power, it turns out, is what you get when you multiply voltage times current, like that. Okay? And you might notice right away, oh, you mean we could do like one of those circles, right? Put the P here, put the E here, put the I here, and do a circly kind of a deal. And it's like, yeah, this works the same. If you were to cover the E, you'd have E equals P over I, which is what you would get also if you just simply divided both sides by I and canceled out the I. You have E equals P over I. Okay, let's get that stuff out of there. Or you could cover up the I and say I equals P over E, or you could cover up the P and say P equals E times I, which is of course what that says. But notice again, it's another 3-in-1, right? 3-in-1 formula. Now, I should mention what this P stands for, well, it stands for power, you know that, I guess. But power is measured in what we call watts, hence the name Watt's law. And the abbreviation for watts is a capital W, and it's power. So E, of course, is the same. I don't have to repeat that, right? E is the same. It's volts. It's like a pressure. I is flow. It's amps. It's a current. It's a flow. It's an amps. So those are the same as Ohm's law. But what is power anyway? Ask yourself that question for a second. It's nice to have an intuitive sense of these quantities. So I usually get the whole class going on what's power. And usually they come pretty close when they start talking about energy. So energy is what you burn to do something, right? Burn it to do some work, whatever the work is. Actually, you could formally define work as pushing something through a distance, but you get the idea. If you want to move, something, you want to do some work, you want to shovel some dirt or whatever, you want to, get up the hill, whatever you're doing, you have to burn energy to do some work. And if it was you, this is you, and you were climbing up a hill, you'd have to burn Wheaties, right? You'd have to burn your Wheaties to get up the hill. Or if you had a motorcycle, I don't want a pickle, I just want to ride my motorcycle. So if you had a motorcycle and you took that up the hill, well, you'd have to burn energy. And in that case, you're burning gas, right? So you either have to burn Wheaties or burn gas or something. You got to use some kind of, well, that's energy. Okay, so that's not quite what P is. P is not energy, it's power. So what's power? Well, here's what power is. Let's say, well, just compare me to the motorcycle. So I get up the hill, right? It's probably going to take a little while. The motorcycle, wing, 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 you're up quickly. That's power. It's the ability to burn energy quickly. Burn energy quickly is power. If you can go from 0 to 60 like really fast, that's because you have a really powerful engine. There's the power. Sometimes people say energy per unit time. You can think of it that way. So there's time is involved with power. It's how quickly can you expend the energy, do the work. Okay, so that's kind of why we're multiplying an E times an I here, because the E is like a pressure, which is like how hard are you pushing, and the I is kind of like a how fast, because current, you can think of current as charge per unit time. It's kind of like a coulombs per second. So this is kind of like the speed, or, well, gee whiz. I wish this thing would read my mind. So this is kind of like speed, and this is kind of like, well, it's the push. So it's like the pushing fast gets you the power. So that's why Watt's law makes sense. P equals EI. Anywho, and then what we can do, so now we got 3 formulas, we got 3 more formulas. I said there were 12. Where's the other 6? Well, you get the other 6, it turns out, by combining these 2 things together. So let me go back to blue. Combining this law with this law gets you more. So combining ohms and watts. So let me just write them right next to each other again. So Ohm's law was this one. Voltage or pressure equals current times resistance, amps times ohms. Watt's law, pressure is equal to, not pressure, power, sorry. Power is equal to, that's pressure, electrical pressure in volts, times the current like this. So you just put those 2 formulas next to each other, and then what you do is you go like this. Hey, this says power equals E times I. But wait a minute, come back up to this formula. This formula that says E is the same as I times R. So what you do is you take the E out and you plug the IR in, and you get P equals IR times I. Right? The IR goes there, and then don't forget this I. So P equals IR times I, which is the same as saying IIR, because you can multiply in any order, and you probably remember exponents, right? I squared r. So let me just write it that way. Power is equal to I squared times r. That's another big, big, giant formula. When I used to have to play with electrical stuff in my formal education days, I had 4 formulas that I always remembered. And that's one of them. That's 2 of them. And that's 3 of them. I said there's 12, but those 3 get you far because again, this formula is actually a 3-in-1. Watt's law is actually a 3-in-1. And then looking carefully at this formula, that's also a 3-in-1 because you can either solve for P, or you can rearrange things and solve for I, or you can rearrange things to solve for R. So this is another 3-in-1. If you wanted to make a circle, I guess it would have to look something like this, right? I squared times R. That way, when you cover the P with your thumb, you get equals I squared times R. There you go. So that would be that circle. We'll actually practice using that on the next page, so we can just, let me just show you another one. Another little formula we can get. So what did I just do? I did E equals IR. Okay, fine. Start over. Let's do, what are you doing? What are you doing to me? I want blue. I said blue. Okay, so we go like this. Take that E equals IR. Take that P equals EI. And we're going to combine them in a different way. What we did up here is we replaced the E with the IR. What we want to do this time is instead of replacing the E, we want to replace the I. Well, what are you going to replace the I with? Well, you'd have to take this formula and say, well, remember I can rearrange this to say I equals E over R. You can use this circle up here. I is equal to E over R. Or of course you can just divide both sides by R. Anyway, I equals E over R. And then you take that thing and you plug it in right there. And what you will get, I'll do it in green again, you'll get P equals E times, and now you're going to stick in an E over R. Now, in order to simplify this formula, you want to think of the E as an E over 1. Okay? You know that, 5 is the same as 5. Oops. 5 is the same as 5 over 1, right? You can always put a 1 underneath for free. So because I'm multiplying fractions, I want to line them up, make them look like fractions. So I take that first E, make it an E over 1. When you multiply fractions, you just multiply across the top and you multiply across the bottom. And so here's our new formula. P is equal to E squared over R. And that's the 4th formula that I was talking about. So we now have in the rectangular boxes, we have the 4 big formulas. This is also a 3-in-1 because we can set up a little wheel. Actually, we'd have to do it sort of like this. That way, when you put the finger over the P or your thumb over the P, you're reading E squared over R, E squared over R. Yep. Okay, cool. So these are the main 4 formulas. So you see where they come from. Actually, these 2 are just like, what do you call them? Definitional. I don't have yellow on this thing. What's going on? Yellow. There. These 2 are just kind of definitional. E equals IR by definition. P equals EI by definition. And then you can rearrange them all kinds of ways. Like I say, there's 12 total formulas if you see them. Now let's do some examples. I think I got like four examples. So I'm bringing back the old, you got to know these prefixes, right? So until you have them memorized, you probably want to keep something like that handy. So it says if we have 10 to the 12th, it's going to be a tera. If we have 10 to the 9th, it's going to be a giga, and so on. And then these are those 4 little circle things that I made. And they're there just to remind us what the formulas are. Again, it's 4 circles, but it's 12 formulas because this formula can be solved for E or I or R. This one can be solved for P or E or I. This one can be solved for E or P or R. This one can be solved for P or I or R. So it's all going to come down to what do you want and what do you got as far as which formula you're going to use. So let's come down here and get started. So this one, we have a current of I equals 48.3 milliamps. The resistance of R equals 145 ohms, and we want the voltage E. Okay, so we've got an I, we've got an R, we want an E. So you come back up here and you look at these circles and you say, hey, do you have an I, an R, and a, that's not an E. Do you have an I? You don't have an I. Do you have an I and you don't have an R? So it's this circle. That's the circle that has the I, the R, and the E in it. That's the circle we're going to want. So maybe I'll just, instead of copying the circle, I'll say first circle. And then once you've got the first circle figured out, what you want to do is you want to say, okay, so what is the actual formula that I want to use? I want to solve for E. They say, hey, give me the voltage. Okay, I'm going to solve for E. Put your thumb over the E. And then it says, oh, so the formula I'm using then is E is equal to I times R. So it's you know, you have to figure out which circle you want, and then you have to figure out, okay, so what's the formula going to be? Then it's just like old homework. All we're going to do is substitute into this thing. Take your 48.3 milliamps, and remember that with the calculator, milli means times 10 to the minus 3, and we've seen how to enter it that way. And I would probably use parentheses on my calculator to show the multiplication. I would enter it on my calculator just like that. I don't think I have to show you the calculator anymore. We've done that 2 lectures in a row. So I'll go 48.3 times 10 to the minus 3. And then that's going to be multiplying a 145. And then I hit the SD button. Where is it? And it's in the scientific notation mode. And so what it's telling me is 7.00 times 10 to the 0. Notice I don't have to hit the ENG button because 10 to the 0 means don't move the decimal. So don't move the decimal, which means I don't have to, you know, this is kind of like having times 10 to the 0. Well, it is 10 to the 0. So that means there's really no prefix. It's just, remember, 10 to the 0 is 1. So this is going to be regular volts, 7.00 regular volts. Again, remember, E is in volts. Our answer is in volts. 7.00 volts. Well, I hope you kind of like that one. Let's try another one. So we have a current I, passes through a resistance R, and what we want is the power P. So we've got an I, we've got an R, and what we want is a P. There's only one of these circles that's going to have an I, an R, and a P in it. Which one? Well, it's not that one. That doesn't have the P. This has the P, but it doesn't have the R. This doesn't have the I. So guess what? It's the fourth circle. Fourth circle. Now you have to look at the fourth circle and say, what's my formula? Well, I'm trying to get the power P, which means I want to cover up the P and see what the formula looks like. And the formula looks like this. P is equal to I squared times R. That's my formula. P equals I squared times R. On my Casio, the way I'm going to enter this, I am going to enter a parentheses. I'm going to put my I in, which is 2.61. And then to get kilo, I'm going to use the times 10 to the X button with a 3. Right? So remember, that's how you enter 2.61 kilo amps. Kilo amps. I'm going to close the parentheses, and then I'm ready to, I have to square it. So remember, there's a square button that we saw how to use. So you have to square that. Then the result is going to be multiplied by, so I'm going to open up another parentheses, and I'm going to type, what am I going to type? 84 ohms, huh? So just 84 will do it. I don't have to say 0.0 really. I hit this, and then I hit equals, and let's see what it says. Parentheses, 2.61 times 10 to the X button, 3. Close parentheses, square button. Open parentheses. 84, close parentheses, equals. And this time I don't have to hit the SD button. It's not giving me a fraction. It's giving me a straight number. It's telling me that the answer is 5.72 times 10 to the 8th. Now remember, we don't want 10 to the 8th. We want a 369. So we hit the eng button just once, boink, and it says 572 times 10 to the 6th. There, that's better. Now I'm going to scroll up. 10 to the 6th means it's a mega. Use a capital M abbreviation. So it's 572 megawatt. Well, power is in watts, so megawatts. Remember, you take the 10 to the 6th out and put the mega in. 572 megawatts. Cool, we're having fun now, huh, folks? Oh, I got 2 more examples. Ooh, okay, let's keep going. This one says, first of all, let me erase all this stuff, because we got a new problem here. This one says, we have power, we have resistance, we want current. So we need a circle that has a P, an R, and an I in it. And hey, weren't we just doing that one? That's the same circle. That's the 4th circle. That's the same circle. Formula is going to be different though, because this time we're solving for the current I. So let's go look at that circle again. I want to solve for the current I. Now you got to be a little careful with this one, because what this formula actually says is it says I squared equals P over R. That's what that says. Let me write that down here. I squared is equal to P over R. And if that's what I squared is equal to, we don't want I squared, we want just I. So I'm going to do something a little loose here. I'm going to say you have to take the square root of both sides. Both sides. So you take the square root of I squared and you get I, you take the square root of the other side. And if Don has given you his little index card yet, you'll actually see this formula written specifically on there. It's one of the 12 power wheel formulas. But I equals square root of P over R. Okay, so again, that was hugely important, right? When you put your thumb over the I squared, keep in mind your formula is for I squared. What you really want is to take the square root. Technically, you're taking the square root of each side separately. The square root of I squared. Now you've got a formula for I, and it's the square root of P over R. So be careful about that step. So, time to enter numbers, right? So what am I going to enter on my calculator? I'm going to go like this. I'm going to first hit the, I'm going to first hit the square root button, because what we've got is a big old square root. Inside the square root is a fraction, so I'm going to hit the fraction button. On top of the fraction is that power. So I'm going to enter my cursor's on top to start, so I'm going to enter the power, 1.88, and don't forget to enter the mega. Mega means times 10 to a power, so you use that times 10 to the X button, front center, the bottom center of your calculator. Mega, again, is an exponent of 6. Oh, I don't have to close my parentheses. I didn't even open one. Okay, cool. So that's on top. I want to get to the bottom of the fraction, so you have to use the arrow down key to get down, and then you can enter the R. You enter it as it looks, 17.2, and then to make sure it's kilo, you can use the time 10 to the X button with a 3. And that's really all you got to do. So I'm going to do that now. I'm going to hit my square root button, my fraction button. I'm on top. 1.88 times 10 to the 6th. I come down to the bottom. What is that? 17.2 times 10 to the 3. I hit my equals, and it's telling me, the first answer it tells me is 1.05 times 10 to the 1. Seems to me like you ought to be able to put your calculator in engineering mode. You can put it in scientific mode. Come on, guys, one more option. Let's have engineering mode. But they don't. What they do is they give you the eng key instead. So remember, our exponent, we want it to be a 0.369 or negative 369. So you have to hit the eng key once, boink, and it fixes it for us. It says, oh, what you really want is 10.5 times 10 to the 0. And remember, the prefix that goes with 10 to the 0 is actually, there's no prefix. So it's going to be 10.5 with no prefix. We're talking about current. Remember, current is in amps. 10.5 amps is your proper engineering notation answer. Pretty cool. I'm going to challenge you to try this one yourself. let's see, what do we got here? We've got an E, which is voltage. We've got a P, which is power. So what is R? So we've got an E, a P, we want R. We want the circle that has EPR in it. So come back up here, erase a lot of this stuff that we don't need anymore. Okay, we need the one that has, let's get this stuff out of here, the E, the P, and the R. So this doesn't have a P. This doesn't have an R. There it is. That's the one we're going to use. It has the E, the P, and the R. So I'm going to write down here, third circle. Now we want to read from that circle a formula for R, because that's what we're trying to solve for. So according to that circle, R equals what? Come back up and look at that again. If I were to cover up the R with my thumb, I would be looking at E squared over P. R equals E squared over P. Now, you don't want to get too reflexive here and go taking square roots. We don't have to take square roots. We don't? No, we don't. And the reason we don't is because I'm solving for R, and the R is not squared. So I'm fine. I'm going to actually square the E inside my formula. That's what I'm going to do. See, up here I had to because my formula was for I squared, and I wanted to solve for I. I didn't want to solve for I squared. So if you have the square on the left like this, you're going to have to take the square root of both sides. But we didn't have that. The E squared is over there. We're fine. We got a formula for R. It's right there. It's a wonderful formula for R. Okay. So let's start plugging into it. How's about? So I'm going to go like, well, I've got a fraction. So I'm going to hit the fraction button first. So I have an upper zone and a lower zone. The cursor starts me on the top. I want to square it, so I'm going to first put it in parentheses, then enter my E, which is 50. And I don't have to type 50.0. It knows it's a 50. But it's kilovolts. Now, you have two options here. You can, if you want to say kilo, oh, that means 1,000, and just enter it as a 50,000. If you're that confident with your prefixes, fine. But it's worth knowing how to do it this way. Use the times 10 to the x button and say, oh, kilo is the same as 3. Then you close your parentheses, and then you hit your square button. So I have just entered this part. I have just entered the E squared part. Now I want to come to the bottom of my fraction, so I hit the down key to get down there. And then I can enter my power, which is 125. And it says kilowatts. Again, you could just enter 125,000 if you're in a hurry, and also you're feeling very confident that you converted that correctly. Or in general, you'd use the times 10 to the x button. And again, kilo is 3, so you put the 3 there. Then you can hit your equals. And let's see what we get here. So, fraction key first. Open a parentheses. 50 times 10 to the 3. Close parentheses, square that. Arrow to the bottom. Put 125 times 10 to the 3 equals. And I don't have to hit SD. It's not giving me a fraction. But what it's telling me is this is what it's telling me. What is it telling me? Okay, it's telling me 2.00 times 10 to the 4th. Okay, again, you want a 0.369 or negative 369 or 12 or something. So because that's scientific notation, but it's not engineering. So I hit the eng button. And it fixes it for me, and it says, really, it's 20 times 10 to the 3. Okay, so to get your engineering notation, what you do to finish up, 10 to the 3 goes out, and in its place goes the kilo, right? And actually, I'm going to put the 0.0 there because we're going to be using 3 sig. Actually, you know what? That's 3 sig figs. That's 3 sig figs. I really should use 3 sig figs. So even though the calculator doesn't seem hip to that, we're hip to that because we're humans. And so we can say, yeah, that's supposed to be 3 sig figs. So put the 0.0 on there as well. That'll make a good quiz question, won't it? Especially I can figure out how to erase it. Okay, I think I'm at the end. Yep, at the end. Let's turn this off.